you remember what the y-intercept of any relation or function is? The meaning of it, not how you find it. Tell me how you find it in a second. What does the y-intercept mean? Yeah, wherever your graph, because now remember our graphs could be lines, they could be curves. Okay. Wherever the graph, and so wherever the graph intercepts, or I'm going to say crosses the y-axis. Think about every point on the y-axis. Think about every point that's on the y-axis. What's common to every single one of those points? Think of every point on a y-axis. What would this point be about here? This would be approximately what? 0.5, depends how much you go up on, right? Okay, so this could be 0.1, 0.2, 0.3. How about this one? The point. 0, -1. Okay, what's common to all that? X is always 0, and that tells us how we find the y-intercept algebraically. We always make x equal to 0 and then figure out what y is. Similarly, the x-intercept is wherever the graph crosses the x-axis. And what's common to every point on the x-axis? Y is 0. Now, we're not actually going to find x-intercepts just yet. Okay? We can calculate the y-intercept. But the x-intercept, for the time being, I only want to know how many there are. Because now that we've got parabolas, there could be more than one x-intercept, because it could go through the x-axis at more than one point. So how do we figure out how many x-intercepts are in a quadratic function? Okay. Well, we use, by using the vertex and the direction of opening. I let that last. Sure. So you need to know where the vertex is and whether it opens up or down, because that tells you how many times it's going to go through the x-axis, if it does at all. So let's look at some examples. Like I said, for the time being, I want you to be able to answer questions like this. I want you to be able to actually calculate the y-intercept, but only tell me how many x-intercepts there are. So how do we calculate the y-intercept algebraically? What do? We make x equals 0. So we plug it in. 1/3 times 0 squared minus 5. And that means the y-intercept works out to -5. Now the number of x-intercepts. You think there's 2? Where are we starting? We're starting at 0. Like there's no parentheses here, right? So that means h is 0. So we're actually starting at 0, -5, and we're going right. So it's got to go through the x-axis twice. So that means there's 2 x-axes. Careful how you calculate. Especially when there's parentheses, the y-intercept. Because it's going to be -4 times 0 plus 2 all squared. So this doesn't just cancel out to 0. We do, what's 0 plus 2? Squared times -4. That's the y-intercept. Number of x-intercepts. Well, this is why you don't have to sketch a perfect graph, just approximately. So where's the vertex? 2, 0?
Oh,
-2, 0, because h is -2. Nothing here, so y is 0, so we don't move up or down. So it's going to be here, up or down. How many times does it cross the x-axis? Just once this time. Because the vertex is right on the x-axis. Now C. Even get C. So x is 0. So we're going to get a pretty complicated one here. We may have to do in a few steps. You're going to have to calculate all of that. I'll break it down by steps this time. So I'm going to do the 0 minus 2 first in parentheses. Get that. What's the next thing I'm going to do? I have to do this. -2 squared. And notice parentheses. What is -2 all squared? Positive 4. -1/2 times 4, or 4/1. -2 minus 3 gives me a y-intercept of -5. And the number of x-intercepts well, where's my vertex? 2, -3, so it's down here somewhere. And does it open up or down? Down because there's a negative. It's going to be wide because of that 1/2, but remember we're just sketching. How many? Really? Where does it cross the x-axis? It doesn't. There are 9. Okay. So we're going to add this to the properties. And like I said, for the time being with x-intercepts, we're actually going to calculate them, but we need to know some new math before we can calculate them. There's a new type of equation you guys need to know how to solve. And the reason we did factoring last year was to help us solve these things. So factoring's coming back. I know you're excited. Last thing I want to do. How do we work backwards? If I give you the graph, you tell me the equation. Okay. So how do we do this? Well, this is the way the equation is going to look. Right? where xy represents a point on the parabola. And hk is the vertex. If you have those two pieces of information, you can find the equation. Because if I find the vertex, I know what h is, I know what k is, I just plug it in. The only one that's challenging to find is a. And this is where we got to use a point on the parabola to help us. So what's the vertex of this line? 5, -4, which means what's the value of h? 5, and k? -4. So I've got these two right away. I'm like 2/3 of the way there. The only thing I don't know is how do I figure out a? How do I figure out how much it stretches? This is where I use another point. Because remember, this represents any point, right? Give me a point on the parabola. Another point besides the vertex. What does it look like we see a point? 2, -1? Okay. So here, this is 5, -4. This is 2, -1. Doesn't that mean that for the time being, I can plug x equals 2 and y equals -1 in to here? So if I plug all 4 of those in, what's the only thing left to figure out? A. So -1 equals a, which is what I'm trying to find, x, which is 2, minus h, which is k, all squared. Sorry, minus h, which is 5, plus k, which is -4. So I've got an equation there to solve. Well, let's simplify this, actually, this. 2 minus 5 squared, 9. So this is a times 9, or just 9a. We should be able to solve from here. What's the next step? To get a by itself? Yeah, add 4. Get rid of this. Add 4 to both sides. Then divide by 9. So I get 3/9, or 1/3, is equal to a. So now I've got all the pieces of information I need to write the equation. So now go back to this form. This time we don't plug in anything for y and x, but we plug in all these values. So therefore, our final equation is going to be y equals whatever a is, which is 1/3, open parentheses, x minus whatever h is, which is 5, close parentheses, squared, plus k, which is -4. Actually seems a little bit more straightforward to find the equation of parabolas than it does lines last year. Lines we seem to have to do a lot of work sometimes. Here, all you need is the vertex and 1 point. So using this, see if you can do the second one. Work with somebody else if you need to, help each other out. the first thing I would do is just sort of label those. 3 is h, 6 is k, 5 is x, y is -2. Create the equation to solve for a using the vertex. So -2 is equal to a, which is what I'm trying to find. X, which is 5, minus h, which is 3, all squared, plus k. So it should look like that to find what k is. So 5 minus 3 is 2, and 2 squared is 4, so 8 times 4, oh, that's a squaring. Well, this is the a, the unknowns, right. Subtract 6 from both sides. So you're going to get -8 equals 4a. Divide both sides by 4, and you're going to get a equals -2. So you've got the 3 pieces you need, a, h, and k. So your final answer, not using y and x anymore, not using numbers for them, y equals a, -2, open parentheses, x minus h, which is 3, squared, plus k, which is 6. Does it open up or down? Thought I'd throw in an extra question.